right, it's great to be here. I'm happy to be here because I was supposed to be in DC. It got snowed out and I barely made it here. So this is so I want to thank Will for moving the schedule around so this could work. So what I want to do is I want to talk about leveraging diversity bonuses, like how we sort of mechanistically how diversity gives us better answers to hard problems. And I want to do this in a fairly rigorous way, but at the same time sort of keep things open for discussion. So I'm switching the order in which I might typically give a presentation. So I want to talk about, normally I would do this. I talk about sort of diversity in a complex world, talk about how diversity produces bonuses, give some data, and then talk about identity diversity, and then talk about actions. But I'm going to shift the identity diversity part up today. But first I just want to present sort of the basic logic of what I want to talk about, which is this, is that the core argument is going to be that cognitive diversity in some ways makes us better, but on sort of difficult problems and in complex environments. So one of the things is, I'm trained as an economist, and so if you ask my sons, if you ask me a question, they say that I begin every answer with, it depends, right? And the reason why is because, most things are conditional, right? So you can say, two heads are better than one. You can say too many cooks boil the broth. You can say he who hesitates is lost. You can say a stitch in time saves nine, right? So for every proverb, there's an opposite proverb. And one of the reasons we write down models and one of the reasons we do science is to figure out the conditions when one thing holds and when the other thing doesn't hold. And so this is going to be the kind of thing of when is diversity useful? It's basically when the problem's hard. So the book that just came out called The Diversity Bonus, sort of a shameless plug that walks through this. And the idea behind that book, and the idea behind kind of most of my work is this is a Charlie Munger quote, that you've got to have models in your head and you've got to array your experiences, both vicarious and direct, on this lattice of models. And the idea is that when you've got something that's complex, right, that means it's kind of difficult to engineer, evolve, predict, explain, that sort of stuff. It's somewhere between ordered and random, so there's patterns and structures there, but they maybe not be stationary. The only way we can really sort of make sense of that is to kind of come at that with sort of an ensemble or suite or lattice of models, right? Lay reality on that lattice of models, use each one of those as sort of a different filter. Graham will talk about this some tomorrow, the sort of random forest. And then let that diversity sort of allow you to get some sense of understanding. So where this relates to identity diversity, and this is a quote by Wendell Berry that leads off my book, where he says, we've been wrong, we must change our lives so it's possible to live by the contrary assumption that what is good for the world will be good for us, is that inclusion, diversity and inclusion have typically been framed from a normative perspective, that they're good for the world, right? It's incredibly good for us to create inclusive workplaces and schools and universities, that sort of stuff. But what this work shows that we've been doing over today and tomorrow is that it's also sort of good for us, right? It's good for market share, it's good for return on investment, good for return on equity, it's good for sort of advancing science, that sort of stuff. So that the sort of canonical example here is that the University of Michigan had a Supreme Court case where we wanted to allow people in based on identity diversity. The Supreme Court allowed some of that, they didn't allow other. Justice Scalia chimed in and he said, look, Michigan faces a choice. You can be diverse or you can be excellent. Actually, he used legal language. He said you can be diverse or you can be super duper. It's the official legal term that he used. And so there's this trade-off then between diversity and super duperness, right? And what I would argue is that used to be true and it's kind of not true. So as Jessica was saying, JF threw out here, that if you think about sort of energy-based tasks, those are sort of no-bonus tasks. So 100 years ago, even 60 years ago, most of the economy probably consisted of things that was sort of non-bonus work. And there were some tasks that had diversity bonuses, but maybe not that many. So this is a northern Michigan logging camp, and these are a bunch of dudes who chop down trees. And what they would do when you went up there to try and find a job is they would see how many trees you could chop down, right? And this was your ability. And if you want to ask how many trees these guys could chop down collectively, you just kind of add this up. Now, I did a little bit of research on this. It turns out they didn't just count the number of trees you could chop down, they also counted your teeth, because you had to be able to eat enough meat so that you could chop down trees the next day, right? David does this at SFI as well, right? It's part of the faculty recruitment thing. It's like papers plus teeth, right? And then we just kind of add it up. So now we're in this sort of information space, like Jessica was saying, and we're sort of in this place where most of the tasks, I think, and especially most of the high-value tasks, have these bonuses. So a simple example, like to throw some, there's a lot of buzz about Amazon's new, location decision. Amazon ships out during slow times about 306 boxes a second. This is Andrea Steves, who was one of my students, and she got a job at Amazon, and she got put in this team of, I think it was 17 people trying to figure out how many boxes and what size boxes should Amazon have. This is an incredibly hard problem, right? It's super hard, because you can't just have like one big box, because you're going to waste a ton of cardboard. You can't have 97 different sizes of boxes, because then people are going to be spending all their time figuring, I wonder which box I should use, right? And what's weird about this is the freaking scale of this problem. So their shipping costs last year were $16 billion. So if you save 3%, that's $500 million, right? And they had like little ideas like, oh, make the poster box a little bit longer and a little bit wider, and you can put 3 cans of tennis balls in there. And that's like a $40 million decision, right? I mean, so you just got to think of like, the scale of this is beyond anything you can imagine, right? And so tiny, tiny margins, right? Tiny, tiny improvements. Like when we talk about these metaphors on climbing on the landscape, a little tiny movement on the landscape can mean a lot of money. I was involved in this project called the Foresight Group, a very small role, and we were tasked with sort of solving or just figuring out obesity, and we did. Right, there it is. And so the thing is, these things, so it's, what's crazy about this, I want to go back to the people chopping down the trees. If you dial in on this, each one of these boxes is a different color. Some are media, some are social, some are psychological, some are economic, some are food, some are infrastructure. This is everything from giant Cokes to genetics to lack of sidewalks in southern Florida, right? These are all reasons why there's increased obesity. So the idea that you could sort of say, let's see who the best obesity researcher is, and then hire the people with the most teeth and the highest obesity research score, that doesn't make any sense, right? Because what you need to do is you need to think about people who sort of cover this range of topics and the intersections of these topics in an interesting way. I was at MoMA a few weeks ago, and this was a really important moment for me in my life because I grew up a hillbilly in rural Michigan, and the rest of my family actually has some sense of fashion. And these were like the 111 most important fashion items of the last century, and 5 of them are things I wear all the time. Flip-flops, bandanas, plaid flannel shirts, and occasionally a pencil skirt, but that's usually just at home. So, but it was great because a lot of the stuff that like I wear was on here, Panama hats, and my family was just, they're joking. It's their only response. But the reason this is interesting is the following, is that what they did is they took each one of these items, fashion items, and they said, you know, you can categorize these things in all these different ways. And one of the ways they did it was they took the UN 17 sustainability goals, and you can take every one of these products and view it through the lens of a different sustainability goals. And so my favorite one was Levi's 501 jeans, which used to be acid washed. So not only did this use like billions of gallons of water, but it also dumped a lot of acid into rivers. Now they use solar-powered lasers to cut these jeans, right? So that it's both environmental and they're not wasting tons of water. So what they could do is they could take each product and show sort of over time how it was doing on these dimensions. So what's cool about that, you think about any one of those fashion items, from white t-shirts to bandanas, has some sort of impact on one of these 17 dimensions, right? And so what we're doing, and this is one of the things we think about in Santa Fe a lot, is that like all these things are intersecting, and if you want to make good decisions in a product environment, you've got to have diversity across these lenses, okay? So here's the 501 jeans, showing how much chemicals they use, and you can see sort of how things changes, and they give them all scores over time. This was done by artists, not mathematicians. So the basic story here is this, that cognitive diversity leads to better outcomes, and we'll walk through kind of why that's true mechanistically in a minute. But as people will say, like, can't you have, this is the Volkswagen leadership that was really good at sort of dealing with reducing diesel emissions. This is, can't they be cognitively diverse? I mean, like, come on, this guy's got a green tie. And it's true that they can, right? But the point is, the extent of their cognitive diversity will probably be limited. So how does identity diversity come into play? And I want to talk quickly, and feel free to interrupt anybody, but there's sort of 4 causal mechanisms out there in the literature. The first one sort of goes like this. It's just the syllogism that identity diversity correlates with cognitive diversity, ergo identity diversity gives you better outcomes, okay? So there's the complicated version, identity to cognition to better outcomes. But there's going to be types of cognitive diversity that are more or less integrated with identity diversity, right? It's going to depend. Here's where we had it wrong, though. So for 30 years, people sort of look like this. So here's types of cognitive diversity: information, your knowledge base, the heuristics or tricks you know, how you represent problems, the models you have in your head, right? So these are Charlie Munger's lattice of models. And the view was, oh, let's look for sort of a gender effect. Let's look for a race effect. Let's look for an age effect, right? And so you'd sort of run regressions looking for sort of like, can we find some link between this individual identity characteristic and differences in how people think? And you can find some evidence for this, but now people talk in terms of what is sometimes the phrase intersectionality sort of encompasses a bunch of things, but it definitely, here I think of it as sort of interactions. Now we recognize that people sort of bring their whole selves, right? So you can't pull out one aspect of my identity, right, and ask how much it impacts. Instead, you've got to look at sort of like me as a person in full, right? So my race, my age, my gender, my sexual orientation, all sort of map, right, to how I think about the world. So Catherine Phillips, so Darryl Strawberry once wrote an autobiography, and somebody asked him, you know, what do you think of the book? And he said, I don't know, I haven't read it yet. I'll let you know after I read it, right? And the same is true of my most recent book, because what happened is Catherine Phillips, who's a good friend of mine, we decided it didn't make any sense to write a book showing that cognitively diverse groups of people are better at doing things than writing a book by yourself. Doesn't make any sense. So I wrote the book, and then Catherine wrote a critique of the book in the book, right? But I wasn't allowed to read her critique of the book until I completely finished my part of the book, because then I would have cheated, because I'm a guy, I would have cheated, right? I would have fixed it. And so Catherine, we had Catherine giving a distinguished lecture at Michigan, and somebody asked about this, and she said, well, she goes, I'll give my definition of what this means. And then she asked me, because I was in the crowd, to give my definition of what it means. And then she goes, now you have no idea what a black guy thinks, right? You can't take her African-American component, my guy component, and then mix it and get an African-American guy, right? And so this has been, and so now when people think about how does identity map to how we think, we really think of people sort of in full. Okay, so that's just sort of the simple story. All these things affect all these things. And again, I mean, people who work at Google or people probably anywhere in the Valley can tell you, if you know what information people search for, you can back out this map, right, with fairly high probability, actually within a thin dime. And so that suggests, at least the first box, information, right, as you change all these variables, you change what information people have. Okay. Second effect, and this is where Catherine's work is really sort of probably the best stuff within the academy. People think differently and harder when they're around identity diverse people, right? So here's Catherine. She says, there's decades of research by organizational psychologists and sociologists showing diverse groups, and here she means identity diversity, are more innovative than homogeneous groups, okay? And she says it's kind of obvious what Scott's going to tell you for the next hour, but it's less obvious that social diversity should work in the same way, right? And what she shows in her work, which is really interesting, if you put identity diverse people in the room, other people just think about problems in different ways, okay? Let me give two examples of this, one that's really linked to identity and one that's linked to just sort of background. I mean, it's educational background. So I have a friend who happens to be blind who's really into architecture, which is confusing to a lot of people. And it's kind of fun, like whenever I'm at a conference with him, I'll say, what do you think of the building? And people are like, is Scott asking the blind guy what he thinks of the building? And then he'll start giving this really interesting answer. And you can just see everybody's world just get completely rocked, right? But the same is true if you're designing a building, if you're designing a public garden and you put someone who is sight impaired in the room, everybody's going to think about the building in a different way. How does this play out? It plays out also on non-identity characteristics. So Andy Haldane is the chief economist of the Bank of England, has started hiring psychologists, not that many, like 2, but he started hiring some psychologists. And he's realized if you put psychologists into the room, the economists act differently because they feel like they have to explain things to these psychologists. And as they do, they sometimes realize flaws in their own arguments, right? Which is not surprising because like without a psychologist there, they'll be like, people are rational. And they look at the psychologist like, maybe they're not rational. And then they think through it, right? That same sort of stuff holds with identity things, right? So if you put the white guys may be cognitively diverse, but they're probably only going to be thinking about white guys if there's only white guys in the room, okay? Third one, and there's strong evidence for this in the academy, identity diversity influences what we study, right? So I guess I pulled the slides from this, but like the simple examples here are if you look at sort of before women became economists, most of the work that women didn't count in calculations of the economy. So anything Ma Ingalls didn't count because it didn't go to market, right? So she was like cooking, right, had a family garden, that sort of stuff. It didn't get priced, right, so it didn't go to market. Another example, Rosario Cabello, one of my colleagues at Michigan, happens to be an African-American woman who runs our Women's Studies Center. She sort of made her career studying infertility among African-American women. It turns out white women psychologists, when they studied infertility, only studied rich white women, right? And that's considered where the problem was. It didn't occur to anybody to study infertility among African-American women until African-American women became psychologists. So there's a lot of evidence when you look across the academy what people study, who people are affects what they study. And then the fourth argument is kind of the Jeff West argument, and this is more subtle, I think, than people think. So one is, if you sort of enlarge the pool, right? If you sort of hire people from every identity group, there's more workers to choose from, so there's more talent, right? That's the standard argument. Like, we want to make the pool larger because there's more talent. But it's also true, if you think of Jeff's work, that there's more diversity. So even if identity diversity and racial diversity didn't create more diversity, just by having a larger pool, you'd have more diversity, right? So this is sort of Jeff's stuff on, if you increase the size of the ecosystem, you get more diversity, right? So if you increase the size of the pool you're drawing from, yes, you're going to get more talent, whatever that is, like people with more teeth who can chop down more trees. You're also going to get more diversity. Okay, so let's go back to this central argument then. So let's accept that cognitive diversity is somehow going to be correlated with or caused by identity diversity, either because it brings it into the room, it asks different questions, it causes other people to think about things in different ways, right? Or you've just got more scale, you're talking about a different, bigger pool, so there's just more ways of thinking in the room. Here's one of the big issues. Michael Cohen, the late Michael Cohen is one of my colleagues at Michigan, who's early contributor to the Santa Fe Institute, used to refer to the sort of business world as kind of a festival of bad metaphors, right? People write sort of popular books and their cheese is being moved and they're rinsing cottage cheese and all sorts of stuff, right? So there's all these like metaphors, but like it's not a science, right? And so one of the things that happens in diversity spaces, people will say, diversity is like a portfolio of assets, right? And that's the main reason we want. And the answer is no. And here's why the answer is no. So the portfolio of assets model, there's no bonus that comes from the diversity. So let's walk through how a portfolio works, right? So if I have 4 stocks, and one gives 8%, one gives 12, one gives 4, one gives -8, on average I get 5, right? The reason you have a diverse portfolio is to mitigate risk, right? If this were the reason why diversity was good in complex systems, my book would be called The Diversity Mitigates Risk, or something like that. Even more boring title. But the point is, right, that that's not what's going on. It's not like, oh my gosh, a problem could arise where we need someone who thinks this way, and then we're going to get the average, right? You don't get the average. So what we want to understand is, how exactly does it work? So what I'm going to do is, I'm going to split this. I'm going to talk about 3 things. I'm going to talk about predicting, which we've talked about some, so I'll go through this fairly fast. Then we'll talk about problem solving, and then we'll talk about creative tasks. And in each one of these, the mechanisms through which diversity operates is going to be different, right? And in each one of them, so we'll have like kind of like real mathematical theorems that sort of show, kind of like what Mert is doing, sort of saying like, in a perfect world, this is what's going to happen. Now the real world isn't going to be perfect, and it's going to like, sort of, put grit in the gears and stuff like that. But the thing is, we know kind of where we're headed, right, or where we could get. If it weren't true, and here's another way to think about this. So we're going to sort of mathematically show this is what could happen if everything were perfect. We may not get that, right? But if things were perfect and we didn't get a bonus, right, then this is a really hard sell, right? So let's think of the 3 reasons why you want to have diverse workforces. One is just the pool argument, right? Demographically, it's something you got to do. The other one is it's the right thing to do, right? This is the Wendell-Berry quote. This is the right thing to do. According to sort of, most people's normative view of the world, it's better to sort of create inclusive workplaces. The third argument, the one I'm putting forward here, is that there might be some benefit from it, right? So what we want to do is we want to sort of understand how big is that benefit? Does it exist? Okay, so I'm going to argue first with a group of predictors, the benefit actually comes not from risk mitigation, but that you do better. You actually get a bonus, okay? And so we'll play with this wisdom of crowdsourcing, and I've got to begin with like my favorite graphic ever. So an undergrad at Michigan made this for me, and people sometimes ask, is it Michigan or Michigan State who has the ag school? And the answer will be Michigan State has the ag school, and here's why. In Galton's experiment, they guessed the weight of a steer. So here's a graph of a steer by a Michigan liberal arts major. Right. Darn it. Oops. This person showed me like, oh, so close. So close. Okay, so the average guess, and it can't be fixed because it came out like in our university alumni magazine thing, so it's on my permanent record now. So the average guess was 1197, right? Mert, I guess, said the actual weight was 1198. And what you can show is this. You can show the following sort of theorem, that the crowd error equals the average error minus the diversity. And this is just an algebraic equality, right? So this is the crowd's prediction. This is the truth. So the crowd minus the truth squared equals the average error of each person. And you might think that's true. So if it were like a portfolio of stocks, your stock return equals the average return, right? But with predictions, you actually do better than the average. And the logic is really straightforward. suppose Graham and I are always off by 6. Suppose we're always off by 6. If we're both 6 too high and we're both 6 too low, then the crowd is just as good as each of us, right? But sometimes if we think about the world in different ways, if he's 6 too high and I'm 6 too low, right, thanks. So if Graham is +6, shouldn't use Graham, we'll say +5, and I'm -5, then when you average this, we're 0, right? So if we have different models of the world, if we make different predictions, that's actually going to make us better. It's not errors canceling out. It's the fact that if one prediction's high, the other prediction's low, if we have different models, we actually do better. So if you look at Galton's data, this is what it looks like, right? The crowd is off by 1.4 pounds. When you square it, it's 2. On average, people are off by like 70-some pounds. Because there's two possibilities here, right? One possibility is these were what I like to call cattle weight guessing savants from the west of England. They could like look at a steer, right? No, so this could have looked like 2 = 2 - 0, right? But if you take Surowiecki's book, they all look exactly like this. The reason why is this. It's selection bias. It's called the wisdom of crowds. So if it's the wisdom of crowds, this number is going to be small. If it's making a book where you're sort of excited by the story, this number has to be big because it's amazing that people got it right. So here's some really complicated math. If this is small and this is big, this number's got to be big. What's cool about the book, though, is Jim's kind of like the opposite of me. He got a PhD in American culture from Yale. So he actually like looked at people and talked to people, and he said the interesting thing about wise crowds is that they're all diverse, but not in terms of the models. He's like they're diverse in terms of their background, training, identity, that sort of stuff. So from an ethnographer's perspective, his wide crowds are all diverse. From a statistician's perspective, his wise crowds had to be diverse in terms of how they predicted, otherwise they wouldn't make the book, right? But we got to be careful about this because this is an exercise, again, in selection bias. It's telling us what's true of wise crowds and what's true. If you define a wise crowd as gets a hard problem right, it's tautological. They have to be diverse. Okay? All right. Here's one from Google. Google found, like, if you look at the accuracy of hires, right, what you get is you get better and better and better as you keep adding more interviewers, right? So this is showing you sort of, and presumably they're not adding better interviewers. You're doing random interviewers. So what you're seeing is this is kind of the diversity bonus, and you see it sort of tails off at about 4. Okay. Here's another example. This is 28,000 forecasts by professional economists. So like in the European Union, when there's 6 main economic indicators, like unemployment, inflation, growth, that sort of stuff, right? In the European Union, there's 43 economists every quarter who make these predictions, okay? In the US, they went to this other side, I think it's like 28 economists that make these predictions. So they have 40 years of these things. The crowd is 21% better than the average economist. That's a big bonus, right? But here's what's super cool about this. So let's benchmark. This is an awesome book. Let's benchmark the average economist at 1. Okay? Let's take the best economist. And so in some of this data, it's Abby Cohen from Goldman. So let's just say it's Abby. Okay? So Abby's 10% better than the best economist. That's probably about right, right? So then let's take the second best economist, who by definition is not as good as her. Let's say he's 9% better, and average him with her. Right? So if we think like with a portfolio of stocks, I've got one stock that's +10, another stock that's +9, I should get 9.5. I get 17. Why? Because they think about fine two economists are always going to disagree for the most part. Right? No, so this is basically saying there's tremendous diversity, right, in these economists. And what you find here is a lot like the Google interview data. You keep getting really big gains up to 2, 3, 4, and then at 5 they sort of flatten out. Right? So one of the empirical questions here, so theoretically is there a bonus? There's always going to be a bonus, right? I mean, that's the theorem is there. The question is empirically, for the given task, how big is the bonus, right? I have one really funny story just to zip back through these. This is like maybe my favorite teaching moment, and it happens kind of according to a Poisson process. It happens kind of every once in a while, and it always gives me joy. Is I teach this online course called Model Thinking, which now has had I think we hit my millionth person a couple weeks ago, right? So that's a lot. That means a lot of email, which is why I won't answer your email if you email me. And the people will send me data from like internal predictions within their firm or a jelly bean contest, and they'll say, it always says the following: Scott, I hope you're sitting down, check this out. And they've plugged the data into this thing, and they're like, it works, right? And so I have this slide that I sent to them that looks like this. And I'm like, check this out. 5 squared plus 12 squared equals 13 squared. Oh, I have a little right thing here because it's not true for any triangle. It's only true, right? So, and I say, check this out. 5 squared plus 12 squared equals 13 squared. The Pythagorean theorem works again, right? Unbelievable, right? But the point is, like, this is always, here's the really interesting thing. The point is, this is always true. It's always true. The question, though, is, how do you find, if you can find people that are on average about equally good that are diverse, it says, like my younger son would say, winner, winner, chicken dinner, right? Because you're just going to do better, right? So the challenge is finding people. So it's not like there's some magic thing that happens. This is something that Catherine and I kind of go a little bit crazy on. It's not like you can just bring in different people. There's going to be some magic bonus, like there's a dust that you pour in, right? What's going to happen is if people have different models of the world that are close to as accurate as yours, you're going to do pretty well. So P.J. Lamberson is at UCLA. He and I made some like totally back of the envelope bad assumptions about like how correlated predictions might be. And we derived something called the not half bad rule. That basically if somebody isn't 50% worse than you, you should average them in, right? And then Preston McAfee at Microsoft looked at, I think, 21 million predictions from this English soccer league where you can bet on who's going to score goals. And he found empirically that's exactly what you get. You basically should listen to someone as long as they're not 50% worse. So I spend a lot of time talking to doctors. This is really effective because doctors pretty much believe they're smarter than everybody else. And you can say, that's right, you are. You're just not 50% smarter than everybody else. So if you just walk around, so you can walk around after today believing you're 49% smarter than anybody else on the planet, you should still listen to them, right? At least when it comes to predictions. Okay, so let's do something super fun. Not that this hasn't been super fun. I first want to give like sort of like one of my favorite examples. So this is Gonzalo Abecasis, who's a professor at Michigan, who's as one of these like 6-digit Google citation people, like 140,000 citations sort of thing. He and Mark Newman kind of like go year to year, who's the most cited scholar at the University of Michigan. And he was involved in this thing where they had a contest between Michigan, Harvard, and MIT, and this is kind of the error rate. So as anyone from Ann Arbor can tell you, if you have Michigan and Harvard and MIT, go at it, MIT is going to lose. So here's MIT in third place. So here's MIT, and it's a small shop, right? So MIT is in third place. Michigan and Harvard kind of go neck and neck, but this guy wins, right? So he's the winner. And he's feeling pretty proud of himself because he had the smallest error rate. After they turned in their data, the funding agency said, the reason we had 3 of you do the same problem is now we're going to have your 3 models vote. Well, it's an incredibly high-dimensional problem. You got 3 models. They're all about equally good. And the MIT law is a little bit worse. They're all about equally good. So how does the average do? A lot better. So who's the best scientist when it comes to predicting? Well, he's the best individual, right? But the best answer is really sort of combining these models. Okay. Let's do something. Let's see how diversity plays into this and see how identity diversity can play into this. So Netflix had this competition in 2006 where people could sort of try and improve on their Cinemax rating system. So the way Cinemax works is that if you type in a movie, it gives you a rating. So if I type in Avatar because I've got these teenage kids, it's going to say 5-star, right? You know, Graham's much more. Graham might get 2-star because he's like a real film buff. Right? So he's not, you know. So this is a hard movie to predict according to people who did the contest. Rush Hour 3, not a hard movie to predict. Let's leave it at that. That's going to be 1-star for pretty much anybody. The challenge was, could you be 10% better than Netflix? So 6 years of data, 500,000 users, 18,000 movies, largest data set ever released. Probably always will be because the Supreme Court says you can't do this anymore because it was too much data. Okay. Here's where diversity comes in, which is really cool. So how do the models work? The models work by having attributes for movies. So Graham will talk about this some tomorrow. We're going to talk about this some as well. People are basically parsing the world according to categories, right? And then you're scraping information off the web about these movies and saying, these are the characteristics of the movie, and here's how much, you know, Andrea or Graham or Murda or Jessica or David likes each of these things, right? So for example, box office, weeks in theater, action, drama, comedy, days available, critical reviews, rating, this sort of stuff. These are sort of attributes, right? The trick here is you can only have attributes that you can scrape from the web, right? So Will and I both, we share this thing where if there's like, you know when they have that music video they put in the middle of the movie? He and I both, we tear up during those. We love those. Right? They can't figure that out. They'd have to have somebody watch all 18,000 movies, right? So this is where there could be things that matter that you can't get. So the early leader in this is Dr. Robert Bell from Bellcore, which was AT&T Research Park. They have 50 dimensions, which is, it's a team, right? This is pretty amazing, right, to have 50 dimensions per movie. They have 107 different models. Their best models, 6.8% better. When they average the models, they're 8.4% better. Why? You know, same story, different verse, right? 107 models, they're all about the same. Average them, you get a bonus. This bonus, this is an interesting sort of thing, because like, depending on the crowd, this can get a meh from undergrads, 1.6%. If you're like on Wall Street, they're like, whoa, 1.6%. You know what I mean? So again, all these things, one of the things that I think is really interesting about this case is that maybe the bonus is big, maybe the bonus is small, you know? You got to, this is where you kind of got to do research. I think this is where hiring becomes so difficult, right? Because it doesn't matter, it matters, if you're adding a model to a model, it kind of matters how good the model is, but it also kind of matters how different the model is from the other models, right? And if you think of people like Charlie Munger as having lattice of models, the real question is, you want to bring in someone smart, right? But you want to bring in someone who's also different. So they're here, 8.4%. And if you go to Jessica's thing, right, what they've got is they're going from the world to a set of attributes, and they're combining these models, right, in order to sort of make some sort of collective prediction. The problem is they can't get to 10%, and Dr. Bell gives this, he's a very dry sense of humor, but he gives this great talk where he talks about his boss coming in and saying to him, dude, you have a job. You gotta go back to your job. You gotta stop doing this movie thing, right? And so he says to his boss, fine, I'll win it. So he brings in, he just calls in other teams. So they call in this team Big Chaos, who are these Austrians who specialize in attaching weights to the various models. So in Jessica's thing, this is the X to Y thing, right? So you've got all these different models going from the world to X. These people are really good at doing Y, and how do they do it? They kind of do it like this, right? They do these sort of Kalman filters. So these are just the weights, right, that you're putting on these different models. So these are just sort of sophisticated ways of coming up with weights. This is good, but it's not good enough. So they bring in Canadians. And the Canadians aren't good at X to Y, they're good at W to X, right? And here's what the Canadians are good at. They figure this out. What is known as, in the sort of history of the Netflix prize, the Will Ferrell snakes on the plane effect. Otherwise known as, there's a category of movies called margarita movies, and here's why. These movies are like margaritas. If you rate them right after you've watched them, they're a classic, right? The longer you wait before giving a score, the worse the movie is, right? Insurance people call this a hazard. This is where you think, whoa, cognitive diversity has just gone way off the charts. So taking this idea from insurance of a hazard rate, like the probability you die, and they're applying it to movie ratings based on whether Will Ferrell's in the movie, right? I mean, it's amazing what people will do for $1 million. Okay, so now they have, when they do interactions between variables, 800 variables. This is unbelievable, right? I mean, even counting interactions, right? So this is incredible diversity in terms of what they can think of, and we'll get to sort of how that comes about in a minute. 800 variables, their best model is 8.4%, combined model is 10%. So they win, but the short version is they don't win, and the reason why is the contest rules say when somebody gets to 10%, the contest ends in 30 days. And the reason why is they were afraid, primarily at the University of Illinois, undergraduates can really quickly get access to the supercomputers, and they were afraid like some undergrad would download the data, hit return, and win, right? Someone did download it, hit return, and beat them by 5%. So not an unreasonable concern. Where this gets interesting is Dr. Bell, when he finds this out, kind of freaks out a little bit. And the reason he freaks out is there's 23 teams from 30 countries, and he knows two things about them. He knows he's smarter. He's got 2 years of data showing he's smarter. He can chop down more trees, and he's got more teeth. But he knows they're more diverse, right? I think it was him or someone on his research team or something like that. They were worried the German team had like some Schadenfreude, category for the movies, right? Like they figure out from the German reviews, right? So and when these people combine their models, they take the lead with 2 days to go. Not because they're smarter. We know they're not smarter, just because they're more diverse. They submit the final things, and it's a tie. And for the first time in all of recorded history, and probably the last, graduate students are punished for checking their work. The ensemble did one last check and then turned in 22 minutes later, so they lost, right? But they didn't lose. They were graduate students. Graduate students never lose. The game just didn't go on long enough. And on their webpage, they say, it's official. They put this up. They say, it's official, Bellcore takes second. And they're absolutely freaking right. How come? I've got two models, equally good, that are obviously wildly diverse. So what has to be better?
The diverse one.
Right. It's a lot better. Right? They're competing on the 5th decimal point. If you add them, you do better on the 1st decimal point. Right? So Belcourt, right, is second. Right? So it's 5 times in this thing you see it. What's great is like Neil Hunt comes away from this saying, wow, this isn't some sort of like touchy-feely diversity thing. This was just kind of like bonus, 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 bonus. You know, they just kept saying, wow, diversity is really nailing this thing for us. Okay. Let's move to solving difficult problems. And here I'm going to give really quickly 2 theorems. So the first theorem is that theorem by Liu Hong and I, where we say there's a difficult problem, there's a bunch of capable, diverse problem solvers. They're going to have sort of, these are just sort of like rugged landscape models. So each problem solver is going to sort of represent the problem some way and then use heuristics. And then we're going to take moderately large teams. So what we showed is in this paper is that the very best teams will be diverse. But one of the things that's really pathological is that as long as the people are capable, if the teams are moderately sized, you actually do better choosing randomly than choosing the best. And the reason why is the very best people will tend to be similar. Think of a space of problem solvers, right? So if it's some giant space of problem solvers, right, like this, there's kind of a rugged landscape in the space of problem solvers. And if this is the biggest hill in the space of problem solvers, so I draw a whole bunch of them and then take the best one, they all kind of look like this, right? And so at some point, you can prove in a fairly, you know, I guess what was odd about this is that no matter how we set this model up, we kept getting results like this, right? And this is now, and people didn't like this result. Somebody, in fact, submitted a paper that was accepted by the American Mathematical Society, and then people got really mad about it, proving that we were wrong, and we were wrong on a set of measure 0, right? So you're a mathematician. So with probability 0, this isn't right, which is true. And some philosopher then gets published a paper saying, this is really cool, right? So he's saying, like, we actually have a paper that's, you know, proving something's wrong on a set of probability 0. And then it also turned out that the person said, I even have simulations where it doesn't work, proving it's not a set of probability 0. But then it turned out this person looked at it and said, no, actually, the simulations are within the set of probability 0 things. So it was a setup as well. So John Kleinberg looked at this and said, I want to do this in a different way. I want to say, let's suppose problem solvers consist of distributions of outcomes. So when we have a problem-solving test, people just kind of throw out a bunch of ideas, and we combine those ideas in some way. And this is work with Maithra Raghu, one of his graduate students. They show the following, which is really great. If you have a linear function, which is like the chopping down trees, the 10 plus 10 plus 12 plus 8 plus 10, then the best team consists of the best individuals. If you have a max function, where you just choose the best one, then they're able to come up with some other sort of statistical test that the best team consists of the best people on the statistical test. It's kind of like sort of a tail measure, right? Like how good of good solutions have. But then they basically show anything other than that. So this, instead of really saying for many, it should say for almost every nonlinear function. What they show is there's no test that you can apply to individuals that determines the best team. So what Lou and I showed is that, and Lou and I have a more general result now that basically says that there's a giant class of problems like this where the no test result holds. So essentially it's this. If there's some complicated way that, or interesting way at all where you're sort of adding up or combining the ideas that people put forward, you can't give a test to individuals to determine the best team because that test is going to make you choose people who are similar, right? Because people are these high dimensional things, so it's not going to work. Here's my favorite result in this space by Microsoft. This is the Ravens progressive IQ test. Right, we have to fill in what's next. This is considered the gold standard of IQ test. Microsoft showed that an IQ test doesn't even work for putting together a team of people to take an IQ test, which is like almost hard to believe, right? So here's what they did is they have British schoolboys, which are a fairly homogeneous group, and here's their individual IQ scores. They divide the test in half, and on the first half of the test, they say, here's your score. And then they compute your contextual IQ score, which is basically saying instead of scoring the questions equally, I'll give you more points for a question that a lot of people got wrong, right? So the score on each question is inversely proportional to how other people did on it. Then they put together teams based on their contextual IQ in the first half and their contextual IQ in the second half, and they show that those things end up being really strongly correlated. So contextual IQ holds true. What that means is if you wanted to pick a team to take an IQ test and have them vote, like what the right answer is, you're better off picking on diversity than picking on IQ score. right? So IQ doesn't even work for picking people to take an IQ test as a team, which is a pretty high bar, one would imagine. Okay, so again, portfolio of assets, you get the mean, problem solving about. Last one, and this is some newer stuff, finding creative solutions. There's a test called the alternative uses test. That's the standard test of creativity, where you give somebody a common object and you say, think of as many uses as you can. And this is sometimes called the brick test, right? Because this is sort of the standard example. So, and then basically your score is how many ideas you can think of. I did this with my undergrads this year, being undergrads. One of them was like looking up what's the best answer ever given on the brick test. The answer is a Barbie coffin. Wow, right? Just let it go. As my yoga teacher would have said, label it a thought, put it away, right? But the point is, right, creativity really comes down to, like, can you think of things that nobody's thought of? So I was doing this thing at the Fed in New York for fun, and I said, give categories for uses of blockchain other than cryptocurrencies. And the Fed is actually kind of a fun place. So first they're like, no, that's it. You know, that's it. I'm like, nobody can think of anything else? Like, no, we're economists. You know, because they were like joking about the fact that they're being, you know, this whole diversity thing, so they're having some fun. So then we did this, and so here's some ideas people actually were really fun. So the names have been changed to protect the innocent, but these were 3 people's answers. Data, hospital, legal, regulatory, art, and scientific, right? And this person has keys, you know, and this person has all sorts of stuff. So their creativity score, Arun's would be 6, he's got 6 ideas. Betty's would be 7, Carlos would be 6. So you'd say Betty's the most creative, she had the most ideas. However, all of her ideas were had by somebody else. So if a game theorist were scoring this, you'd use something called Shapley value, where if you're the only person that has an idea, like, you know, keeping track of who owns art, you'd get a score of 1. If 2 people had the idea, you'd get a score of 1/2. And if 3 people had the idea, you'd get a score of 1/3. And if you do that, right, Arun's Shapley value is 3.5, Betty's is 3, and Carlos is 2.5, right? So again, you run into this thing that the best team wouldn't necessarily consist of the best people. So my book, I talk about this a little bit. I've done a bunch of these alternative uses tests in my class with students. And what you see is that some identity types are really good at some classes of problems, right? And so then what ends up with, and they find the same solution. And so then what happens is the best teams end up being identity diverse. So that the best example I had from my class is there's this game I play where you put the alphabet like this, right, all the way down. And then you have somebody like give a famous sentence. So maybe, you know, John Donne, whoso lists to hunt, or something like that, right? And then you have to think of who is a famous person, right, with the initials AW. And the rule is they have to have like a Wikipedia page with 500 words in it or something, right? The people who are best at this are like guys who follow baseball. No, I mean, really, no, this is true, right? So, because there's a lot of famous baseball players, it's like, you know, 25, and people who follow football, right? So they win. But the problem is if you have a team of 6 of them, they have the same answers. So this year, the one I did in class, which was so great, at M, we have O next to it, right? The team of the 6 best people did not get it, the MO. And I'm like, so have you heard of Michelle Obama? And they're like, oh my God, Michelle Obama. She doesn't play baseball, right? You know, because they were basically using this sort of like sports heuristic, right? So all of the lower half, this wasn't gendered, it was just the baseball guys, because like they were just invoking the think of sports players heuristics, and they all missed Michelle Obama, which is kind of amazing. Okay, so let's extend this, and this is a paper not yet written, but I'm hoping it'll be done this century. Suppose that there were n possible ideas, including the Barbie coffin or something down here, right? And so that someone's ability would be kind of the probability that they'd think of this use of blockchain or the brick, right? So like your ability is just, on average, this is like economists do this all the time, psychologists, what would your expected value be on the alternative uses test, which should be the sum of these probabilities. So let's suppose there's let's do it in simple, in just 2 cases. Let's suppose there's type 1s that have a 20% chance of thinking of the first use and a 10% chance of thinking of the second use. But again, you want to think of there being thousands of uses here, right? Let's just do 2. I just need these ratios to be different. And type 2s have a 5% chance thinking of the first and a 15% chance of thinking of the second. So the type 1s are better than the type 2s, right? You can do this more generally, and actually I was going to ask Jessica to help me with this, because there should be some really nice way to do this with a construct a more general model. Suppose I have 20 type 1s. Now the problem of them not thinking of the first thing is 0.8 to the 20th, which is only 0.1. probability of not getting the second one is 0.9 to the 20th, which is 0.12. Now there's a 12-to-1 ratio, right, in terms of the likelihood of not getting the second compared to the first, whereas when we started out, we're weighting those things equally. But as we get further along, right, now this thing, there's the 12 times less likely to think of this one than that one, right? So if I have k type 1s, adding another one, even though he's high ability, is likely to just, is equally likely to give me these two things. But a type 2, right, so here's the type 1, their margin of values, let's just put weights on it of 1 and 12, is going to be 1.4. The type 2, right, who's less has less ability, if I do their weighted score, is now 1.85, right, because they're more likely to think of different stuff. Right? So when you think about if you have a creative task, the idea is not, if you're hiring one person, yeah, the idea is like how many things can they think of. If you're hiring multiple people, what you really want is, this is I think more of an information story, right? I mean, David and Jessica, it's kind of like how different, like what's my Kullback-Leibler distance between my vector and your vector in some sense, right? But then as I take more people of the same type, I'm really amplifying, right, differences in probabilities, making people of the same type worth even less. Right? That's sort of the idea. Okay. Again, right, doesn't work. So quickly some data on research. So if you think of academic research as being creativity plus problem solving, the NIH did this big study on science of team science. They found teams were more innovative. The other thing I really like in this is they found an inverted U of diversity. And this is a snoozer, by the way, if you get this. The NRC has, who's been on an NRC panel? Like the National Research Council, which is the research arm of the National Science Foundation, does these giant books that are summary things, and they tend to be snoozers, but you can read, these are sort of the 4 points at the beginning, and what they find is that if you have no diversity, you don't do very well. As you increase diversity, you do better, but if you have too much diversity, you do worse, right? They find women are more collaborative, and they find, again, not surprisingly, is where that coordination becomes super crucial when the task becomes harder. So Brian Uzi looked at every paper ever published, like 24 million papers, and this got cut off. It's the number of authors. So in 1960, most papers had either 1 or 2 authors. You notice the N is changing on the side. Now most have more than 5. The reason why is if a cutoff for a paper being influential is 100 citations, you're 4.5 times as likely to get one of these good papers if it's team authored. Now you could say, right, so here's the other, this is a great graph they've got in this. This is a kind of his whole research. Obviously, this isn't single authored. This was a jointly authored paper. So imagine there's a co-authored paper. This is kind of the bonus from it being co-authored. This blue box represents the bonus you get from having people who've had papers that have been cited a lot in the past. So this is like the ability bonus. This is what they call the atypical combination bonus. The paper's called atypical. And what this is they do this funky thing. What they do is they sort of say, are you citing papers together that haven't been cited in the past? So like Danny Kahneman won the Nobel Prize in economics, took psychology plus economics. So he's citing papers in psychology with papers in economics that nobody's cited before, right? So that's an atypical combination. Now if Kahneman hadn't been good, this box would go away and he'd get just this box. So the big green box is if you have talented people and atypical combinations. So this is the interaction term, right? So there's a bonus for, so what's really interesting about this particular, if you think of academic research, there's a bonus for diversity, there's a bonus for ability, and there's a bigger bonus for ability and diversity, okay? If you look just at the social science paper, this is work by Melissa Schilling, who's got a fabulous new book out. I think if you order a book still, you get an Elon Musk bobblehead. It's about genius. She looks at just the social science papers and just at the good social science papers to say, is it author count that's driving it? So is it just that there's more citations somehow? It turns out as you increase the number of authors holding everything else constant, this is an odds ratio, you get 20% fewer citations. And what's really driving it again is this atypical connect. If you connect things that haven't been cited in the past, you're 15 times more likely. Now that may seem really amazing. It's not, because it's really hard to do atypical connections that are good, right? The same sort of true with cooking. If you just randomly grab 2 things from your, like, that peanut butter chicken still is failing. Okay. Richard Freeman looked at this, same thing. This is just number of email addresses. So if you look at Uzi's data, hold everything else constant to the best extent you can. If you're a social scientist and do research with someone from a different university, you're 11% more likely to get one of these papers, and in the sciences, 8% more likely. Holding everything else constant, just if they have a different email address. That's weird, right? Part of the reason for that, though, is, again, there's a selection bias. I'm only going to go to some other email address if I can't figure it out myself or know my home institution can, right? So that's probably a proxy for diversity. more than just the address itself. Number of references have an effect, right? Number of past papers, so these are sort of quality things. And then homophily does, Rickshaw did this really cool thing, it's also with a co-author, where they used anthropological techniques to figure out the sort of ethnic identity of your last name, right? So my last name, Page, would be classified as Scottish. My wife's Bednar would be classified as Slovakian, not Czech. She used to think she's Czech, but she's not. And so if we wrote a paper together, we would be considered people from different ethnic groups, and so homophily means, are you from the same ethnic group? And if you are, you do worse. So what Richard says is, he only looks at the science papers, so it's only 18 million papers, and he says, here's how you get a B+. Work with people from your same school, from your same ethnic group. Right? Okay. Quickly, and then we'll hopefully have a bunch of time for questions. What about all the sort of stuff people have been talking about kind of in the questions, like inclusion, right? So Jennifer was talking about this, components plus the interactions, right? So this is some, Sheen Levine has this wonderful quote that he calls the siren call of sameness, right? We're making important decisions, or when things go bad, we tend to look for people who are just like us because we're smart and they're probably smart too, right? So this is an amazing paper by Brian Uzi again, and then Daniel Romero, who's one of my colleagues at Michigan, who's part of the many people that have come out of Strogat's lab. Where they've got it's a financial services firm, I don't know which one, let's just say it's JP Morgan. And this is and what they do within this financial services firm is that people, when they refer to Apple, they don't say Apple, they say AAPL, so they just use the ticker symbol. And what they have is they have these emails going between people, and they also have the volatility of the stock price. What they find is when this is during a normal period, people are emailing all sorts of people. When volatility increases, people only email their close friends. So they turtle up, right? Now some of this could be because, I was thinking of murder stuff, some of this could be because of speed, right? But it also sort of seems like maybe the wrong thing to do, right? You should probably reduce the number of people, but you should be drawing people from more places. So one of the things you can think about in this space, and maybe Graham will talk about this, maybe he won't, but there is a question of can you use data analytics on your own emails and your own communication structures within your firm and ask, are people turtling up when they should be spreading out, and are people spreading out when they should be turtling up, right? But these are things you can actually, in the past when people talk face to face, that's not measurable, right? Now this stuff is measurable. The culture, a quick aside of this, I'm trained as a mathematician, mathematical economist, a game theorist, and I wrote this book on the benefits of diversity, but it was purely a theoretical book. And then I went to visit companies, and my very first company I visited, Boeing, they were like, well, let me tell you where we are on our diversity journey. And I'm like, oh no, I am so in the wrong room right now, right? You guys have a diversity journey for real? And but then you realize that no, this is true. Every company you go into has these cultures, right? So I use this all the time. Even if 80% of you heard it, it's worth it for the other 20%. Where David Foster Wallace has this graduation speech where there's two goldfish swimming, and this older goldfish comes up and says, "Morning, boys, how's the water?" And they're confused. He swims away, and then they say, "What the hell is water?" And this is so true, in every organization, right? Every organization is different. There's this culture that's how people can talk to one another, what they can do, and no one's really kind of aware of it. And so Andrea and I worked for a firm, big firm, and I walk in, I'm talking to the CEO and the leadership, and they look pretty much exactly like this. And I said, tell me about your firm. And the CEO said, we are a meritocracy. So again, I'm a bad poker player because I didn't grow up around sophisticated people. I had literally a physical reaction when this person said, and I just couldn't hide it. He's like, we're a meritocracy. I'm like, and this is a smart dude. He goes, you seem like that didn't seem right. I'm like, I'm looking at 9 white dudes. I'm looking at, and he said, to his credit, our Indian woman is sick. Right? Which was true in his defense. No, but it was it was half a joke and half he's just overcome with fear at this point because he realized he just said something incredibly stupid. Because if you're running a company, and this is the basic sniff test. If you're running a company with 130,000 employees from 35 countries, and somebody comes in from the outside and is meeting your top 10 people, and you're saying we're a meritocracy, and they're all from one ethnic group, you're not a meritocracy, right? Andy ran data on this, and if you ask the people in the primary ethnic group who are male, is it a meritocracy? What was it, 95%? Yeah. And among the women, it was?
10, none.
Yeah. So it turned out it was a meritocracy for these guys, right? No, but this is the water thing, right? This is what's so cool about this. So the key, the quick takeaways, then we'll open up, is I think the key here is you've got to act like you want it, right? So this is sort of, one of Astro's quotes, that it really is these sort of different ways of thinking about problems that matter. And Kim Scott talks about this as well, and I think this is one of the hard things about getting, when Jennifer was talking about the interactions, not just the components, is that, or Jessica was it, no, Jennifer was, so Kim has this idea, which I really like. She says, you have to care about people personally, and you also have to challenge them directly, right? If you challenge people without care about them, you're in this obnoxious aggression box. We were talking about this with the Academy. The Academy, one of the big issues that, like at Michigan, we're in this ruinous empathy box, right? No, in the sense that we really do care about people personally. We're trying to create these really inclusive environments. And this isn't like Orchid Land or anything else, but we often err on the side of not challenging people directly, right? In order to get these bonuses, right, you really do have to sort of, people have to feel safe. They have to feel validated. I mean, your point earlier was so spot on about feeling authentic, right? You don't get authenticity unless you're way up on this dimension. But at the same time, if I'm like, it's so great to have all these diverse people in the room, and I'm not actually challenging people's ideas and getting them to share their ideas, you're in this box, right? And this, you can put company names in here if you want later on. We can play like some sort of company, and we'll all get Intel right. All right, so one thing you can do here is think of attributes or dimensions. So this is a fun thing. Think of attributes or dimensions of direct reports or colleagues that are relevant to your team's performance, right? So here's a creative task. Suppose you've got you're putting together a team, you might think, what attributes or dimensions do people want? This is the brick test, right? If I'm putting together a team, you think like, what should people know for that team? This is the brick test. Think of answers. Then go ask somebody else. What would you think of? And you'll find out, wow, they thought of different stuff, right? Then what you can do is you can assign values for your direct reports on those dimensions. That's not a bonus task. That's an easy thing to do. And then you can sort of say, is it the case, this is kind of the identity diversity question, if I look for diversity on the things that are relevant, does that map back to identity diversity? And you'll find that it typically does, right? So if you say, I need someone who's like lived in a different country, or I need someone who's had different experience, or I need somebody who understands this product market, or I need someone who's qualitative, I need someone who works this way, right? Then you go back and see, does that correlate with identity? You often find that it does, right? Which dimensions matter depend on context. So if you go to Harrah's, they'll say we need quantitative people on every decision, and we need quantitative people, because they've got tons of data, right? But you just have data, but they're also an entertainment company, right? If you go to Northrop, they'll say we need people who've done government stuff, and we need people who haven't done government stuff. Because like, if you do government stuff, you're really good at process, but you like don't know the word innovative. You'll hopefully get that next semester, right? But if you haven't done government stuff, you're going to get done in. So different companies care about different things, but you'll find that these things correlate with identity. This is a William Blair. I was at William Blair last week, and I said, identify a task that's both complex and high value to William Blair, and then ask two other people to select which of the relevant dimensions are germane to that task, right? William Blair is an investment company. And what's interesting, when we did this, right, people think of different stuff. So one of the ways you sort of achieve these bonuses is you get people thinking in terms of diversity and diverse attributes and diverse ways of thinking, as opposed to just different bonuses. And then to really achieve these things, you want to select teams that provide both coverage, right? So think of that sort of obesity graph, as well as depth on the attributes. And then you can 360 this and say, like, do the attributes you thought of matter, right? All right, let me stop there.